There it is. Okay. Yeah, this week I thought was a lot trickier.
Mm-hmm.
So hopefully we can get through this. Okay, so the first question, the scores on the quantitative portion of the GRE are approximately normally distributed with mean, whatever that letter is, and a standard deviation of whatever that is. So would it be 150.8 and then the 8.8?
I'm sorry. Trying to find it.
Oh, you're good.
So, um, okay, so preparation part 5, part 2. Is that?
Yes.
Okay. And so what? Oh, you said the mean of 150.8 and then 8.8.
Yeah.
Yeah. Yeah. I like skimmed through these, so I'm trying to like remember. Okay.
Yeah.
Um, okay. And what proportion of the people who take the quantitative portion of the GRE will score above 665? So for that one, because you take the standard deviation equals, and then so the mean. All right. So is it 665 minus 150.8? Is it
Um,
always the mean that like you're minusing?
yeah,
Okay.
I think
I
so.
think that I also got confused on that. Like sometimes I would take the mean and then like minus the other. Okay. And
Yeah.
then you divide it by standard deviation.
Yep.
Okay. Mm, and then you just punch it into the, what is it? The little normal probability applet,
Yep.
which is very,
Convenient.
which is very good. Okay. Um, so then for the second part, if the student scores the 10th percentile, what would be the corresponding z-score be?
Would it be the negative 1.2816?
Yeah,
Okay, perfect.
I think so. Yeah.
And then what is the quantitative GRE score for a student who scores in the 10th percentile?
The quantitative choice. Okay. So then we take the mean again, and then you add that to the negative 1.2.
I think so.
1, blah, blah, blah. And then and times it by the standard deviation. Okay. Okie
Did you get around 140?
Mm-hmm.
Okay, perfect. Okay, the mean speed of hydrogen at room temperature is 1800 m per second, I guess, with a standard deviation of 600. At room temperature, the speed of hydrogen particles is approximately normal with a population mean of, would it be the 1800? And then with a standard deviation of 600.
Yeah.
Okay.
Yeah.
Got it. So what is the probability that a randomly selected particle has a speed over 2,500 meters per second?
So again, the mean minus, so 2,500 minus 1,800 divided by 600, 1.1667.
Yeah.
Then you punch that in the thing. Okay. Okay, next one. What is the probability that a randomly selected particle has a speed that is less than 2,500? What is it? What's ms? What does that stand for?
Which one?
Just the ms?
Meters per second.
A second. So again, the same thing.
So tired. It's been a long.
No, I'm so tired right now. I am just dang.
Okay, so we're on D, right?
Mm-hmm.
Okay, what is the probability that a randomly selected particle has a speed that is less than 1,500 meters per second? You do 1,500 minus 1,800 divided by 600 and then negative 0.5.
Perfect. Then when we punch it in, we get 0.3085.
Okay, awesome.
What is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500 meters per second? Okay. Subtract over. So what's the mean again? So it's 15. So 1,500 minus 800, 1,800. Wait. Subtract the.
Oh my gosh.
I don't know this.
I still don't get this whole lesson, basically.
I don't know. The concept. Many groups will probably need specific help on this problem. Okay.
Cool.
We'll come back or
Yeah,
because I don't really know.
I don't get it at all. So what is the third quartile of the speeds of hydrogen at room temperature? Would be the 674491. And then you do
Wait, what's this one for?
F. Because you take, what's it called? The mean, no, not the mean. My brain is like pudding right now. Okay. Yeah, so you take the mean and you add the number that's at the 75th quartile, which is the 0.674,
Uh-huh.
times that by the standard deviation, which is 600. And then you get 2,204.4.
Okay. Sweet.
And then determine whether the data represented in these QQ plots are normally distributed or not.
So just whichever ones are straight.
I think we just have to like say which ones are normal.
So then plot A would not be normal.
No. Neither is
B.
B.
Nope.
C?
C? I don't know. Is C not? It's kind of, I guess not. Kind of wavy.
I just pulled up the answer key and it says it's
What is this?
normal.
No? Okay.
But it does say even though the points snake around the line, this happens with normal distributions as long as they're consistent. So as long as it keeps going, we're good. And D seems okay. Yeah, it's normal. And E
Yeah.
and F. I don't think F is normal.
E's normal. Let's see.
Oh, we're opposites. E is not normal. And then
Oh.
F is normal. See,
Why? Wait. Oh. Okay, so I guess it's E's kind of looking like the S one, I guess.
Okay.
Slightly. Okay, and then F's pretty straight. Okay.
Okay, let's do the best part, the quiz.
This time. Oh dear. And it's bad. We're both like super tired. Oh, like wake up.
It's not too long. And I know the answers to the first two.
Yay.
Where'd my notes go?
16 problems. So number 3 is 1.
Yeah.
Under certain circumstances. False.
False. And the next one's true, right?
Yeah, true. Use the following image. So
None of those does Z score? Or no?
isn't it the 1 and oh wait, maybe I'm confused now. Let me see. It's oh wait, yeah. Isn't not none of them?
I'm trying to find.
The Z score and then How many standard deviations away from the mean? Yeah. So
Do we want to come back to that one?
yeah, let's skip that one. No. Skip that one. Ah.
Would it be C?
Yeah, I think so.
I feel like that's a trick question.
Greater than 1. Or is it B?
Well,
I think it's either B or C, right?
which of the following elements of the figure represents the probability that the random variable D will be greater?
Then it's.
Is
I
it
think
9?
it's right.
I don't like this question.
um.
Let's go back to that one too.
Okay.
Okay, according to the 6895 rule.
So that's 68.
I think so, and
Is someone trying to get in? Is that what this sounds?
I think so. We need to figure this out.
Okay. So number 8, 68, and then number 9 is plus 9.
Okay, hopefully.
What proportion of the values from this random variable will be -1 and 1?
Wait. Keep clicking out of everything. Okay, so for number 8, it's the 68, right?
Yeah.
Okay. And then those are
Okay, guys, that was weird.
sorry.
No, you're
Proportion
fine.
of values from this random variable will be -1 and 1.
Okay, this looks different. So there's an option just to watch, but watch it live.
Okay, so for number 8,
Okay.
it's the 68, right?
Yeah.
Okay. And then, okay.
Okay.
My gosh, my brain.
Values from this.
Okay,
Okay,
we're on number
9.
Yeah. I'm following along with you guys.
Okay.
That's the thing, is I could watch you guys, but I wasn't a part of it. That makes sense?
Yeah, kinda. Not really.
Okay. But I'm pretty sure number 7 is B.
Number 7.
Yeah, you guys were talking about it. You weren't sure if it was B or C.
Mm-hmm.
So 2.
Because that line right there represents C, correct? Or yeah, that line. So anything over would be B, would be greater.
Okay, yeah. For number
6.
Number 6, I think it might be A, but I'm not positive. So yeah, we'll just come back to that one like you
that works.
said.
Okay.
Yeah.
So for 9, you just plug it into the little app thing, right?
Mm-hmm.
Okay. 1, 2.
Did you guys get 0.6827?
Um, mm. Are we putting, wait, let me actually, hold on. Because we're supposed to put it in for the z-score, right?
Well, I
that-
thought that, like, if you click out of, like, just make the whole chart or whatever white, and then click on the middle space between -1 and 1,
Uh.
it says 0.6827. So
Okay.
0.683 after you round it, I guess. Or no, you would keep it 6.8 or 0.682. You don't round it.
Okay. So 0.682.
I think so.
Suppose random variable z has a standard normal distribution. Use the normal alpha to answer the question. What proportion of the values from this random variable will be between -2 and 2? So is that when you shade it all in?
Yeah, but
The 2 and the -2?
that doesn't seem right, you know.
Yeah. Okay. I have to go, but I'll be back in like a few minutes. Sorry about that.
You're good.
Okay, so
Because for number 11, it would be 1. Because that's the entire part or whatever curve.
so if that's the case, wouldn't it be 99?
The 99.7.
Yes.
Let's go with that.
Because we're doing, if it's all the way to 3, that's like, or would that be 100? Okay, so it's 68, 97, 99.
Yeah.
Right? Okay, yeah, so it would be 99. 99.7.
Is that for number 10 or 11?
That would be for number, sorry. That would be for number 11.
So 100? Or 1?
For 11 is 99.7 because it's the 3, and then 10 would, if it was 2, it would be 97.
Okay.
Does that sound right?
Well, I'm just confused because, like, the first answer, it's supposed to be 3 decimal places, you know? So
Oh, yeah.
that's why I'm just confused.
So, okay, I'm sorry. Number 10 is 95. 95 and then 99.7. This whole lesson was confusing. I hated it.
Yeah. I got 0.998 for
998.
the last one.
Okay.
I don't know how right that is, but... And then between... I just don't know how to do the between -2 and 2.
Well, if you go to the app, this is how I'm doing it. I don't know if it's accurate. Hopefully. Anyways, looking at the applet, so it's normal distribution, so it's 1, and then 2, and then 3, 4, right?
Yeah.
So in the middle of those 2 1s is 68. In the middle of the 2 2s
Hello?
is
Hey,
95.
sorry about that.
You're all good. We're still confused. Nothing new.
Which number are we on now?
Number 10 and 11, kind of.
Okay.
And then what did you guys get for number 8 or number 9? Sorry.
I thought it was 0.682. Or point... Wait, why is that a different number?
Oh, duh, because it has to be in a decimal place.
0.684. Don't know why. I'm so confused. Okay. Let me reset my little graph here.
Violet. Sorry. Stop chewing my jacket.
0.682 for number 9. And then number 10, you would do 2 and 2, 0.954.
0.954.
I think so. So then the last one would be -0.997.
Okay.
So then for number 12, it matches the rule, right?
So wait, 11's 0.997?
0.997, yeah.
Be careful of your answers.
So it follows the rule. Which is kind of cool, I guess. We're a nerd about that kind of stuff.
Oh, cool, you know. It's all good.
Okay, the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the U.S. The protein requirement is given in the terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. So, this seems complicated. Okay. And it says use it for questions 14 through 17, but it only goes to 16. Cool. Okay. So what proportion of the population have a protein requirement that is less than...
That.
Yeah. Why can't these be multiple choice?
Seriously.
I literally have no idea how to even attempt doing this.
I don't.
Let's begin the LF5 group meeting. Number 3. The number of grams of It's all
Okay.
equal to mass of each being per kilogram body weight. The population is protein requirements.
I have the video up right now
Okay.
from Brother Doria. I'm just watching it to see how he does 13, 14, 15, and 16.
This is
Perfect.
Good.
what proportion of the population protein requirement is less than 0.6. Give your answers in the market. So to do this, we have to convert this number into a z-score first, which
Okay.
we're using
So we have to convert 0.60 into a z-score.
Okay. That would be z-score calculator. I got 0.253.
253.
Or that should be it. You said 0.6, right?
Yeah.
Yeah, it's 0.253347.
Okay.
formula for the z-score.
Wait. Okay.
Z-score equals x9 is the mean.
So he's doing it all in Excel.
Just like that. So I'm going to
Ow.
type in standard deviation, which is constant. X is 0.6. The mean in this case is given as 0.66.
Okay, now he's taking the mean.
Z-score so our z-score is let's actually do this.
Okay.
Negative 3,
So what he's getting is negative
negative
0.857.
Is this with the actual questions that are on here too?
Yeah, they're the exact same questions.
Okay.
Let me I'll double check it just sure, but it's the same class. Yeah. So he got 0.857. Okay. So 16.
I think Dominique's trying to get in.
Yeah.
I think so.
Go.
Okay, so he took the z-score
negative
and the mean. Oh, go back.
Sorry, guys. Hello?
Hey.
How are you?
Hey, good. How are you?
Good.
Good. Okay. Sorry about me being super late.
No worries.
I think as we do it on Monday, it'll be so much better for me because
Okay.
there's so much else things going on. Okay, sorry about that. But yeah. So let's get these questions then. It's really nice that they're not so bad.
Do you know how to do it?
So are you guys? How far did you guys get?
We're on the last 4 questions.
The last 4.
Yeah.
Oh dang. Ooh, 16. What?
So
Okay.
he took the z-score and minused it, so he minused it from the mean
Okay.
and then divided it by the standard deviation.
Okay. So.
Does that make sense?
Yeah.
Okay. Keep
Okay.
watching. He's going to go over like all of it.
Okay.
So our z-score is
Point.
So is this the thing from Brother Doria?
Uh-huh.
Okay.
negative
Have you watched it yet, Dominique?
I have.
Okay.
I'm just trying to open it back up again.
question is what proportion of
Okay. And then the portion of 14 required.
So are we on question 13?
Yes.
Okay.
I think we're on number 14 now. 13, it was negative 0.857.
Okay.
And then,
what proportion population
okay, and then for less than,
the left of z-score is
okay. And then for that one, we plug what we got into the applet. So
Okay.
if we got, so negative 0.857, so I said, right? 857.
And then you would just do the shading stuff, right?
Yeah. Just want
I don't like this class anymore.
It just got so interesting. What do you mean you don't like the class anymore? Just kidding. This work though.
Just
I
frustrating.
heard that it's really hard. It gets harder.
Oh no. Why am I here?
Yay. Okay.
Hey! I thought these were getting into stuff. Okay.
Okay, I feel like everything hates me right now. Please. Okay. Um
So you would put in the negative
okay.
8.7.
Okay.
So okay. So the negative 8.5, that's not the z-score, right? That's the area. That's
8.
I'm
That's
sorry.
It's
That's the area thing, right?
Wait, no, that's the z-score.
Gotcha.
So you plug that in,
Mm-hmm.
and then for the area, you want to make sure that the left-hand corner is the only one that's selected. And stop. Okay, sorry guys.
So we want the hang on, let me get the question again.
And I got 0.1957.
Mm-hmm. Me too.
That's what I got too.
Yeah.
That's what I got too.
Is that for
0.9.
14?
I believe so.
What was it again?
0.1957.
So I guess it's 1.96. So you have to round it.
Yeah, to the nearest decimal.
Yeah.
Earlier it said not to round it. So,
Yeah.
It says give your answer as a decimal, accurate to 3 decimals places.
okay. So you would round it?
Yeah.
Yeah.
That would be 1.96.
Yeah.
Okay, 15.
Reserve requirement is less than 0.70 grams. Give your answer to the.
Yeah, and he rounds it in the video too.
Okay.
Okay.
More than
Oh wait.
more than
Okay. I'm sorry guys. So yeah, so for number 13, it's 0.196.
13 is?
14. That's 14.
No, let me double check. I'm watching him do it. Yeah, so number 13 is 0.196. Number 14, we're going to do the same thing except for highlight everything except for what we just had highlighted. Does that make sense?
Yeah.
Yeah.
So everything but what we have highlighted.
So the answer would be 0.804.
3.
Yeah, so that's what you got?
Mm-hmm.
4. Okay.
0.
And what portion of the population have a protein requirement that is less than 0.7? Okay. So
What
if
was 14 again?
14 is 0.804.
Okay, perfect. Thank you.
You're welcome. And then, so number 15, we would just have to do the same thing, but with 7.70.
let's say what proportion of the population have less than. So we need to convert this to a t-square.
Okay.
Minus 6 and deviations 0.7.
Okay. So the z-score of the 0.7 is 0.571. So if we plug that in,
Okay. And so we would be shading from the
To the left, right?
to the left. Yeah. Because it's less than, right?
Yep.
Okay. And the answer I got was 0.716.
That's what I got.
So what number do we put in the z-score? Is it?
I got 0.571. That's what you plug into the z-score.
0.571.
But I got something completely different. I got an area of 0.2840.
That's what I have.
That's what you guys
Yeah.
have?
That's what I have.
Wait, really?
Did we both just do it wrong?
Well, or we just did it wrong.
Okay, what's the area that we use again?
I have 0.716. That could be wrong.
We plug in 0.571 into the area though, correct?
No, you put that into the z-score. What I just said was the area.
Okay.
So, okay, are you shading in the middle as well, or are you just shading to
Just the left side.
just the left side? Okay, because that's the one because if you do just the left side, that's what I got. The 2.4.
Oh.
Yeah, that's not bad at all. Just the left side for me. Oh, I think I know what I did. Okay, so for the z-score, let me see.
Because the z-score is right, I think. It's just, it needs to be... So if it's less than, do we have to shade the middle too, or is it just the...
It should be just the left side.
It should be just the left side?
Mm-hmm.
Okay, because that's what I got confused about.
And
Okay, if it's just the left side, then it's 0.284. That's what I got.
Okay, yeah, that's okay. That's what we got.
I see now.
So how do you know when to do both, and like both the middle and the left, and then well, yeah. How do you know when to do that?
Less than 7.
I think it just depends how the question's worded.
Yeah, that's
Okay.
what I'm thinking.
Yeah.
So one would be an example where you would shade both the middle and either the right or the left. You know what I'm saying? Like maybe I'm just a little confused by
I
that.
think it would just be like when the number's like further down on the line, where like it would cover like from -2 to 2,
Okay.
So I think it will specify when you need to. But like with these ones, since it's just like what's more than, less than.
Yeah.
Okay.
Last question. Do this.
There's a probability that a randomly selected person will have a protein requirement that is between 0.60 and 0. Okay, so this is like what you were just talking about, right?
Yeah.
Okay. So,
This is the one that the homework said, like, you need help to do it,
Oh.
basically. That it's difficult.
okay, but we've already found. Okay, this should be easier, right?
Yeah. Wouldn't you just take the 0.84 and subtract the 0.284?
Maybe. Let's see. Who that Gloria does.
And we want less.
Oh. Okay. So Dominique actually had it right the first time.
I did.
The 0.716.
Okay.
Yeah.
That's what he got too.
For
716.
0.716 because you highlight both the edge and the middle, and that's what you end up with.
But why do you do both though? Like now I'm confused. I'm so confused. Does he explain why you would highlight both of those?
Let's see.
Was that for number 14 or 15?
That
That
was
was for
15.
Okay.
I don't know. This is brilliant though. Thank you, Brother Dory. You're the best.
Oh, okay. I think I get it.
Okay, please explain, because I'm just like, I don't know.
I don't know how I'm going to explain it. Okay, so the 0.70 is the z-score.
Okay.
So when we plug that in, depending on like what side it's on, so but it's positive. So it has to be on the positive side over. So anything less than the positive z-score. Does that make sense?
Yeah.
Yeah, no, yeah, it does.
Yeah.
There's like the negative, yeah. Okay, find the probability that the randomly selected person will have a protein requirement that is between 0.60 and 0.70. Okay, so what are you thinking for number 16?
Well, wouldn't you take the one that is... Okay. You would subtract the smaller area from the larger area. So wouldn't you do 0.804 minus 0.716?
I think so.
That's how it makes sense to me, but I could be completely wrong.
Which, let's see, what do we get? So to subtract 0.804, or
You take 0.804,
and then minus
the 716.
7. Okay. 1, 6. You get 0.088.
Yeah.
Okay.
Are we going with that?
Yeah. I have not submitted first yet. So I will take the plunge. Did we talked about number 6? Yeah.
Do we not?
So wait, okay.
So then,
So the answer to 16 is 0.088?
Yes.
Okay. Okay, hey, I'll take the plunge this time. I just want to make sure my answers are like what you guys have.
Okay.
Okay. And I just did this by myself. Okay, so starting with 3, the curve density thing is it's equal to 1, right?
Yep.
Okay.
Mhm.
Under the density, number 4, is that false?
Yeah.
Or is that true?
Yeah.
Yeah, okay. All right. Okay, we're good. The normal density curve is symmetrical, right?
Mhm.
Okay.
Uh-huh.
Sweet. True. All right. Number 6 is C. That's where the z-score is, right?
Okay.
Number 7 is B, right?
Yeah.
Okay. Sorry, I'm just like, am I right?
Uh-huh.
Well, I was
And then number
wrong.
8 is, whoa, it's wrong?
No, I'm saying like if I don't say something, then you're good.
Okay, thanks. All right.
You're welcome.
Where'd it go? Okay. Number 8 is 99.7%. No, it's only one. I'm sorry, so it'd be 68%.
Yes.
Okay. And then you get 6.683.955.997, right? Yeah? Okay.
Is it 0.682 or 0.683 for 9?
I have 0.682.
I have
Uh-huh.
2 just because it said like, you're supposed to round it though, right?
Yeah, we're supposed to.
So I think it's 6.
So would it be? So what? Okay, hang on. I'm just gonna look at the applet again.
Okay.
Okay, so this one. I think you would round it to 3.
Okay. I trust.
Yeah.
So
Oh,
point
that's so nice. Yeah. So 6. Yeah. And don't you worry, because I'm doing it first anyway, so we'll definitely know. And then, so it's 5.9. Oh, it's 0.955, and then 0.997. This is demonstrating the 60, 68, 95, 99, whatever rule, right? Yep. Okay, and
So
then
number
we did.
10, wait, sorry. So number 10 is rounded to the 5?
Yeah, I just kept that the same because you have to have 3 decimal places.
Okay.
So 0.995. Okay.
Yeah, and then for numbers 11, I got 0.997.
Yep.
Mhm.
Okay, great. And then number 12 is the values match the 68, 90, that rule. Yeah. And then we did 13 through 16 together, but just to make sure I got the right things, 0.196 is 13.
Mhm.
0.804 is 14.
Yep.
15 is 716. Obviously, that's a point. And then 0.088.
Yes.
Okay, sweet. I'm submitting. Oh, we got something wrong. Or I got something wrong. Let's look at that.
Just one wrong though, right?
Yeah, it's just one. It's the last one.
Of course it is.
Yeah.
I'm okay with getting it right.
Ah, okay. I got the answer. I got the answer for you guys, so you guys don't have to get it wrong.
What is it? And how do you get
It is okay. So the formula. Hang on. Let me just hang on. I can send you guys an email real fast so you can look at it. It's just the formula. So what it does, it has the So we subtract the 0.7116. You subtract that by the 196. So you subtract the 2 z-scores that you get from the other one.
We just subtracted the wrong one.
Yeah, or is that the area? I'm sorry, I think that's the area. Is that the area? I don't know, but this is the answer. So it's 0.520.
Do we have to put zeros before all the decimals, or can it just be like point whatever?
I'm not sure. I just put the 0. That's what I do.
I don't
So.
think it matters.
I don't think it would matter, right?
It shouldn't matter because it's just a placeholder.
Okay, what did you get? Point?
So it's 0.520.
Okay.
Sweet.
Awesome.
You guys.
Sweet. You guys are the best.
I actually really like our group. You guys are nice.
Good.
No, I'm really excited about the semester with you guys. But hey, okay, so we're going to be doing it on Mondays and Wednesdays now at the same time, or should we do earlier? Or
I think we should do a little bit earlier. Cause it usually
I
takes
think that. Okay,
Well,
that's
don't
awesome.
Work, Tabitha.
Yeah, that works. Yeah, because
I get.
it's not before like 6-ish. Well, no, as long as it's not before like 5:30 your guys' time, I should be fine.
Okay.
Okay, I get out of class at 5, so we can do 5:45. Does that work for everyone?
Yeah.
Yeah, that should work.
Okay, so 5:45 Monday, and yeah, that's fine. Okay, awesome.
Okay. Have a good weekend, guys.
You guys too.
You guys
Yeah,
too. All right,
All right.
bye.